This is a video for the second unit review for Blended Algebra 2 Unit 2 review, or Unit 3 review, I'm sorry. We won't do every problem on the review, but we have some similar but slightly different problems than what I did on the video for the review number 1. Alright, so the first question says to solve by factoring. And here I have 3 terms. Make sure when you solve a quadratic, we said in the last video, you have to make sure it's set equal to 0, which is what we have. If I have 3 terms, that means I have to factor by splitting the middle. Now to split the middle, I multiply the first term and the last term, which is negative 24. You need to find 2 numbers that multiply to negative 24 and add to negative 5. That means I need a positive and a negative. So my numbers, I think I'm going to skip right to the value here is going to be negative 8 and positive 3. Negative 8 times 3 is negative 24. Negative 8 plus 3 is negative 5. Once I choose those numbers, the way I split the middle is the first term comes down, the last term comes down, and the negative 5x gets split up. Negative 8x plus 3x. Now I factor by grouping. I group the first 2 terms together and the last 2 terms. I look for a GCF. From the first group, it looks like I can pull out a 2x. When I divide 2x out of both terms, I'm left with 3x minus 4. Now for the second group, the only thing it looks like I can pull out is a 1. Now typically we don't pull out a GCF of 1, but for split the middle we can. When I divide a 1 out, it doesn't change the value of what's inside the parentheses, so I stay with 3x minus 4. So my factored form here takes what's in the parentheses, 3x minus 4, and multiplies it by the GCFs, 2x plus 1. Now this has all been set equal to 0. I just didn't write it every time. So to solve this quadratic, you then take each factor and set them equal to 0. So what you do now is the last one you're going to start by adding 4 to both sides. Get 3x equals 4. And then you divide by 3. So x here is 4/3. That is one solution to this quadratic. The other one, I start by subtracting 1, and then I divide by 2. So our solution, the second solution to this quadratic is negative 1/2. All right, so that's how we do split the middle to solve by factoring. We did GCF and difference of squares on this other review. Now we're going to solve by graphing. We're going to type this quadratic into Desmos. Now, again, just like the last problem, we have to make sure we're set equal to 0, which we are in this problem. So I'm going to take my Desmos, and I'm going to graph 5x squared plus 8x minus 13. And when I graph it, I'm looking for the solutions, which are the x-intercepts. So these x-intercepts appear to be at negative 2.6 and 1. So here x is negative 2.6 and 1. Now 2.6 is a decimal, but it is a nice rational decimal. Because 1 and negative 2.6 are rational numbers, you would say that yes, this quadratic is able to be factored. All right, let's skip down to some simplifying square roots. Like the last video, when you simplify square roots here, let's slide this down just a little bit, we need to think about the list of perfect squares. Okay. You need to know what the first 12 or so perfect squares are so that you can easily break down your square root. So when I look at the square root of 24, I have to look at that list and think which is the biggest square root that goes into perfect square that goes into 24. It happens to be 4. So I'm going to rewrite this. Square root of 24 is the same as radical 4 times radical 6. 4 times 6 is 24. When I simplify that, radical 4 breaks down to be 2. Radical 6 stays the same. So that is your final answer. Now we talked about in the last video that you can check that in Desmos. If you wanted, you could type square root of 24 into Desmos, get your decimal, and then type your simplified answer in. You should get the exact same thing, which we do, which means that you simplified correctly. All right, now we have negative 3 times negative, or radical negative 56. The negative 3 is a coefficient out in front. So that negative 3 is going to hang out with us for a little bit. We're not going to do anything with it quite yet. When I have a negative under the radical, I'm going to have I in my answer. But the first thing I do when I break down the radical is write that as square root of negative 1. So that's square root of negative 1 times the square root of 56, right? That gives me what? Negative 56. Now I'm going to take another step because I'm not done breaking down radical 56. I rewrite the radical 3 times, or the negative 3 times the radical negative 1. 56 actually has a perfect square that goes into it. It's actually 4 again. So write that as radical 4 times radical 14. Now I'm fully broken down, and I can simplify what's left. The radical 14 doesn't change. The square root of 4 is 2. The square root of negative 1 is I, and I still have my coefficient of negative 3. Now to get your final answer, you multiply the negative 3 times the 2, which is negative 6 I radical 14. That's more complicated, but that would be your final answer. Finally, in 11, we have a fraction. It's not difficult when you remember that the square root breaks up over your fraction. So you can rewrite this as the square root of negative 4 over the square root of 9. Now we simplify what we have. When I have a negative, I can rewrite that as the square root of negative 1 times radical 4 over radical 9. And then everything breaks down really nicely for us. Square root of negative 1 is I. Square root of 4 is 2. So the numerator is 2I. Radical 9 is 3. So your final answer is 2I over 3. Or you have to make sure that you understand how to break down radicals so that you can do the quadratic formula and complete the square in the next couple of problems. So we start here with the quadratic formula. It's up in the box on the top right. In order to use the quadratic formula, we have to be set equal to 0. Here we are not. So I need to start first by subtracting 8 from both sides, because that will get me 0 on the right, and the left-hand side will be 3x squared plus 5x minus 8. Now I'm all set to use the quadratic formula. I start by labeling A, B, and C. A is the first coefficient, B is the second value, C is the last number. I put this into the formula, so I will have x equals the opposite of b. So the opposite of 5, which is negative 5, plus or minus 1 long square root. Under your square root, you put the 5b in parentheses. So 5 squared minus 4 times a, 3, times negative 8. Make sure they're all in parentheses. And the entire thing you just wrote down goes over 2 times a. Now I simplify this. The negative 5 plus or minus the square root stays the same. However, you're going to use Desmos to simplify the radicand. Only what is under the radical. Do not type a radical into Desmos. You're going to type 5 squared minus 4 times 3 times negative 8 into Desmos. Right? And use all the parentheses. So 5 squared minus 4 times 3 times negative 8. And you get a value of 121. All right, so let's see. So we'll put 121 under the radical. All over 2 times 3 is 6. Now we need to break down the radical. And you should know that square root of 121 is equal to 11. So really what I have here is negative 5 plus or minus 11. No square root anymore because it was a perfect square over 6. Now when I have no radical, I need to break my answer up into 2 rational values. So I'll rewrite it. Negative 5 plus 11 over 6. And negative 5 minus 11 over 6. Now we simplify it. Negative 5 plus 11 is 6 over 6, which equals 1. Negative 5 minus 11 is negative 16 over 6, and that simplifies to be negative 8 over 3. But if you didn't simplify it fully, that's okay, as long as you can tell me. Oh, sorry about that. Let's try to get that go away. As long as you can tell me what the simplified answer is, or what the rational answer is, negative 8 over 3, or negative 16 over 6. We're good. Okay. All right, so that's the quadratic formula with two rational answers. Now let's talk about completing the square. And I think, oh, not good. All right, so for completing the square, you have to be set equal to 0, which we are. And the other thing about completing the square is that you want your leading coefficient here to be 5 or to be 1. It is not. So what you have to do is start by dividing everything by that 5. Because when I divide by 5, I'm left with x squared minus 2x minus 5 equals 0. I now have a leading coefficient of 1, which allows me to do the completing the square method. So to complete the square, we start by adding the constant to the other side. My left-hand side then starts off the same, but in place of this 5 here, I add a box, because I'm going to fill in that box. The right-hand side also has a box, 5 plus box. To fill in the box, you take half of the middle term. So you take negative 2 divided by 2 and square it. Negative 2 divided by 2 is negative 1. And any number that's negative that's squared is going to be a positive. Negative 1 times negative 1 is 1. So I'm going to add 1 to both sides. Now, when I do this, I have the right-hand side here. 5 plus 1 simplifies to be 6. The left-hand side factors. It's a perfect square trinomial, so the factors end up looking exactly the same. They both get an x, and then the value of the number that you fill in both parentheses is half of the middle number, and half of negative 2 is negative 1. All right, we condense the left-hand side, which means it's x minus 1 squared equals 6, and all I have to do is take the square root and get x by itself. Get x minus 1 equals, now in front of the square root, we always write plus or minus, and radical 6 does not break down, so you can leave it as radical 6. Lastly, you add 1, and when you add 1 to both sides, it gets squeezed in front of the plus or minus. So your final answers here are 1 plus or minus radical 6. Those are irrational values, so you could not have factored the original quadratic. All right, so we have a couple more here. I think we're going to talk about, yep, just 3 more. We're going to choose a method. So on your test, you might have to pick a method to do. It doesn't matter which method. You can do factoring, complete the square, or quadratic formula. But you have to think about which method is going to be the best one to do here. So I'm actually going to, I'll tell you which one to do, and then we can talk about it more if you need help choosing a method. Now, complete quadratic formula always works. Factoring doesn't always, complete the square doesn't always. So if you're not sure, just use the quadratic formula. For this first one, I have 3x squared minus 27. And there's only 2 terms in this quadratic. And so if there's 2 terms, you can use quadratic formula or complete the square, but it's going to be easier just to do factoring here, because you should notice I can factor a GCF out of 3. I'll have 3 times x squared minus 9. Now, notice, I can still factor what's inside the parentheses using the method of difference of squares. That 3 comes down in front. Now, difference of squares means I take the square root of x squared, which is x, and x goes in both parentheses, and then I take the square root of 9, which is 3, and I get a 3 in both. I put a plus and a minus, and you're factored. But in order to solve this quadratic, I now have to take each factor, with an x, and set it equal to 0. So take x plus 3 equal to 0, x minus 3 equal to 0. I do not have to set the GCF of 3 equal to 0 because it does not have an x, so it's not a factor that finds me a root. It's just a GCF. We'll talk about what the 3 does later on in this course. I solve by subtracting 3 and get that 1x intercept is at -3. And over here I add 3 to both sides, which tells me that I get x equals 3. So I used the method of factoring, and I got the roots of -3 and 3. The next one I'm going to look at is 17, x squared minus 8x plus 3. All right, well, first of all, let's talk about why factoring is not going to work here. I would have to split the middle, which would mean multiplying the 1 and 3. And if I multiplied 1 and 3, I need to find two numbers that multiply to 3 and add to -8. The only numbers that multiply to 3 are 1 and 3, and those are never going to add to -8, which is why this doesn't factor. Now, I can use the quadratic formula, but I'm actually going to use the method of completing the square. Completing the square works when this middle number here is even and the leading coefficient, a, is 1. I have those qualities here, so I'm going to do complete the square. You could use quadratic formula, however. So we just did complete the square. We start by moving the 3, which gives me x squared minus 8x plus a box equals -3 plus a box. To fill in the box, I take half of this middle term, -8 divided by 2, and square it. -8 divided by 2 is -4, and -4 squared is 16. So 16 goes in both boxes. Now, to continue, I add the right-hand side up. That gives me 13, and the left-hand side factors. Just like the last problem, both factors get an x. In order to figure out the value that goes in next to the x, I take half of the middle term of -8. Half of -8 is -4. All I have to do, and I forgot to write method here, is complete the square. All I have to do here is condense the left-hand side, square root, and solve for x. So I get rid of the square by square rooting, and get x minus 4 equals plus or minus radical 13. Don't forget your plus or minus. And then I finish by adding 4. Okay? I squeeze the 4 in front of the plus or minus, and get my two roots are 4 plus or minus radical 13. I don't break down the radical because 13 is not a perfect square. Those are two irrational roots, which is why we were not able to factor. Last one. I'm going to use the quadratic formula here. Now, the reason I'm using quadratic formula, I said if the middle number is even, that's a good time to use complete the square. However, in order to use complete the square, the first term here has to be 1. And that's not true in this case. This is not 1. 3 is not equal to 1. So we can't use complete the square, but we can use quadratic formula. I'm set equal to 0, so I'm going to start by labeling A, B, and C. For the quadratic formula, I take x equals, now the opposite of b is -2, plus or minus my long square root. I take b in parentheses and square it, -4 times a times c, all over 2 times a. Now, just like the earlier problem, I'm going to simplify the radicand. That's the number under the radical here. So don't type the radical into Desmos. Just type 2 squared minus 4 times 3 times 5. Okay. So we'll start, put your parentheses, 2 squared minus 4 times 3 times 5. And I get -56. Squared and -56, and that all goes over 6. Now I think, let's flip back. I think we did -56, the square root of it, earlier in this review. So let's see. We did. We found that the square root of -56 was equal to radical 4 times radical 14. So instead of refining our numbers, we'll use radical 4 and radical 14. We know over here. Okay. All right. So let me rewrite this here, these for us to see. Square root of -56. I already have a negative, so I have a square root of -1. We said we were going to use the perfect square of 4 and then the not perfect square of 14. Well, the square root of 14 doesn't break down. Square root of negative 1 is I. Square root of 4 is 2. So I can replace the square root of negative 56 with 2i radical 14. When I do that, I get negative 2 plus or minus 2i radical 14 over 6. And remember, all I did here was replace the square root of negative 56 with what we found. If you leave your answer here, I'm going to be happy that you got that far. However, if you can notice that the 2 and the 6 are all even, I can divide each of those coefficients by 2. I'm not allowed to change the radical. So you could simplify this to be negative 1 plus or minus 1i radical 14 over 3. Those are equivalent, but if you at least got to the left box, all we have. All right, let your teacher know if you have other questions. Finish up the problems on the review to get a little bit more practice.